have to understand as to what is friction, which is the base of the next chapter. That is the friction and the frictional force. For that, what you have to understand at the beginning is that there will be no friction on smooth surfaces. If you don't put any outside material on any smooth surface, then there will be no friction at all. So it means that friction will be there only if we have got rough surfaces. And rough surface means what? When there is a body, instead of being plain like this, has got ups and downs, then such a surface is called a rough surface. For moving a body on this surface, it is not easy. Supposing to move a body over here, everything is the same. Same shape, same size, same material. And there, if you want a 10 Newton force to move the body, then on the rough surface, everything is the same. No difference otherwise. Then, same details. Now when you apply the force, then to move the body, the minimum force needed will be more than 10. So it should be somewhere around 12 Newtons or so. So that is the difference between a smooth surface and a rough surface. Here, in one of the classes, a student asked me, "Sir, if there are ups and downs, so what? Because of that, how do you mean that the body will slow down, or how do you say that the force applied will be a greater force?" For that, you must have a clear understanding about the surface and the body. So the surfaces are rough. And what you have to note is like this: the bottom surface of any body will also have ups and downs. So when you place the body on the rough surface like this, and the body also will have a rough surface like this. So the ups and downs of the body, when it is moved, will contact the projection of the surface. So it will be somewhat like this. The body will have some ups and downs. The surface on which the body is moving will also have ups and downs. When you apply a force, see here that the two bodies come in contact, because of which this projection is opposing the motion, because of which you have to apply an additional force. So like that, because of projection on the surface and also on the body, there is an opposition. That opposition is called friction. The force on account of this opposition is what is called frictional force. Friction can also be termed, for that matter, well, any opposition can also be known as resistance. So what you can say is that the resistance offered to the motion, or you can as well say to the relative motion of a body while moving over a surface, reason is this: while moving over a surface is defined as friction. So the reason for friction is this. Of course, here there is yet another concept that is attributed to it. There are many who claim that friction is existing because of the presence of charges at the interface. Some say that charges are existing because of friction. Which one is correct, I do not know. If you see one side of the coin, you will see the symbol. If you see the other side of the coin, you will find that there is total money, which is worthiness of the coin, the number that will be inscribed. So both are seeing the same coin but on two different sides, so it will appear to be different. So that is why if you ask me, what I will say is that it can be either way. The clouds moving in opposite direction, when they collide, because of that collision friction is there, Because of that, what happens is positive charges on one cloud, negative charges on the other cloud interact, and because of that we have thunder, lightning, rains and whatnot. So, it can be the either way. Friction is produced because of electrification. So, if you ask me, the only thing I will say is it can be any way around. So only because of charges friction is produced. Well, I am not I'm not content with it. Leave out all that. It is not required for our subject matter. Still, for the sake of knowledge, both are possible is what you have to keep in mind. Okay. So we have got an idea about the friction and the frictional force. Many people think that friction opposes the force which we apply. So, when we have got a force, we apply and the body is kept on its surface, then that friction force at the interface will oppose the motion. That is what many people are thinking. It is correct most of the times, but sometimes it is correct most of the times, but sometimes it is the other way around. For example, you take this plane. Your body is kept on this plane. In the last class we have studied that for this plane which is making an angle alpha, so the weight will be acting, the component of the weight which will be acting parallel to the plane will be mg sine alpha. So it is mg sine alpha. To stop this motion, we are applying a force upwards. This is applied force. Still, motion continues. Supposing 10 Newton force is necessary, I am applying only 5. So, balance 5 will be remaining unbalanced, because of which the motion will continue downwards. If the motion is downwards, friction will act opposing the motion. So, the frictional force will be acting opposing the motion. So you can see that the frictional force and the applied force both are in the same direction. So it is not always that friction opposes the force. But one thing is definite, that friction opposes the motion. Whatever be the direction of motion, friction will act opposing that. So friction opposes the relative motion, or if only one body is moving, then you can say that the friction opposes the motion, and so on it goes. Okay, so many people just are satisfied with that, then whatever be the formula, they will try to work out problems on that. It is not at all enough. Half of the problems will go wrong. That's why I have told you, the +1 level physics is not that easy. If you miss one concept in between one step and the other step, you are gone. You lose 5 marks. 4 for the correct answer and negative mark -1 for giving the wrong answer. So we have to further probe into friction so that we will be well aware of all the pros and cons that is there when a body is subjected to friction. See, many people are thinking that the frictional force is a constant and it is equal to mu into r, where r is a normal reaction. It is not correct, wrong. So for that I would like to start from scratch. Rough surface is there, and let us keep a body over a rough surface. And it is rough like this. The question is, what is the frictional force? They know the formula for frictional force, mu r. What is this mu and also what is this r? R we know it is the normal reaction of a body. When a body is kept over a surface, there will be normal reaction. So that R and mu. All about mu we are going to study in a short while. So many people think that the friction force is always mu into R. So they find the value of mu r and they will say that that is the frictional force. Not necessarily. See, if there is no force in the forward direction, friction also will not be there. Supposing mu into r after calculation is equal to 10 newtons. You are applying 2 newtons and the frictional force according to you is equal to 10. Frictional force is something you don't apply, which comes the natural way. Body is moving on a rough surface, at once the frictional force will also be generated. So, when I apply 2 Newton force, and according to you the frictional force will be equal to 10, how is it possible that I apply 2 Newtons and opposing force which is generated in the natural way will be equal to more than 2, equal to 10, say? It means that if you remove the force, no force is acting, then frictional force will move the body in the opposite direction. Is that possible? Then there will be no body at rest. So that is why this is having, or this friction force is a maximum. It does not exist always for all situations of the force applied. No, not at all correct. So if 2 Newton force is what I apply, then the frictional force also will be only equal to 2 Newton. Okay. Supposing I apply a force of 3 Newton, frictional force also will become equal to 3 Newton. So whatever force you apply, if that increases, friction force also increases. What do you understand from that? A very important point. If frictional force keeps on changing, then the frictional force is a variable force. Many people are thinking it is a constant. Not at all a constant. Remember that. So, 2 friction force 2 Newtons, 3, 4, 9, friction force is also 9. When you apply 10 Newton force, friction force also becomes equal to 10. When you apply 11 Newton force, friction force is 10. So this is a maximum value. When we apply a force more than the maximum value of a friction, after that friction will not increase. The frictional force will not increase. So from 0 up to the maximum value. So this is not the frictional force, it is the maximum value of the frictional force. After this, further if you increase the applied force, friction force will still remain at 10 only. So these are the information which is not given in most of the books, but without this knowledge you cannot solve any of the problems. Okay. Now, this 3 Newton is balancing the 3 Newton force that we have applied. Or if you want to take the maximum force here, say 10 Newton, and the force that we are applying is only 4 or 5 Newtons, or say 3 Newtons, it is not balanced. So, under any circumstances, the maximum value of the frictional force only can be used for balancing all the forces in the different directions. So, if you use maximum frictional force, and this is balanced by our applied force 10 or even above, then you can balance all the existing force. One side it is 10, another side it is 3, you cannot balance it. So, you can balance the forces in different directions when friction is there only when maximum friction has reached. Before that lesser force, you cannot balance the different forces in different directions. So these are all the secrets which you have to remember. Whatever be the less force applied, friction force also will be equal to that lesser force. If you put the maximum value which is not there in the applied force, then there will be no balancing. Or what we can say is that you will get a wrong result. Then don't ask the question that if there is no balancing, will the body move? If there is no balancing by taking the maximum friction, maximum frictional force, then if this is more, then the body should move opposite. We are not supplying that frictional force. Comes the natural way. So, it means that just like that if you leave the body and because of frictional force the body will continue to move, then a person can go to moon straight away in very, very less time without supplying any energy. Because if we keep a body downward, and if because of friction it starts moving up, sir, when it moves up, then how friction will be there? another student asked some years before. See, when the body is moving up, the air will oppose the body moving up. And that only is called air resistance. In air, there is a resistance. For solids, there is a resistance. That is a mixing friction force. And for liquid also, there is a resistance, and that only there is called viscous force. Air resistance, the frictional force, and the viscous force are all one and the same thing, but it is applied in different mediums. Gas, liquid, and solids. Okay. All very good information is what I have mentioned here. So make a note of all that. And as a part of our program, whatever I am explaining is being recorded. And by making a little payment, you can also get the recorded version of whatever be the speech that has been accorded during my teaching. So that you can see it repeatedly again and again, all these important points. So what happens is that when lot of informations are given, then you will have a tendency to forget. So whatever is important, that is why you have to just repeat. Just repeat, man. Repeat it. So that is why it is always good to have a copy of the recorded version, so that when in doubt you can look into it, and I give you the guarantee that your problem will never go wrong. Yeah. Alright. So then, so you have got a complete idea that when our applied force is equal to the maximum value of the frictional force, or even more, then only you can balance the forces in different directions. Otherwise cannot. If this is the situation, you cannot balance. You can yourself see 3 and 10. How is the question of balancing coming out here? No direction you can balance the forces then. Okay. So as you increase the force more and more, the frictional force also increases. When you get the maximum value of the friction force, further if you increase, the friction force will not increase now. That force beyond which, that frictional force beyond which this frictional force will not increase, that is called the limiting force. Because maximum value has been reached, maximum limit has been reached. So at that time the frictional force is called the limiting force. When our applied force becomes equal to the maximum value of the friction force, so this becomes equal to balanced. After further if we increase the force, friction force cannot increase, so there will be some extra unbalanced force for the applied force that will now move the body. So if you keep on increasing the force, body will not move. If that becomes equal to the limiting force, then only the body will move. Okay. When the body moves, or when the applied force and the maximum value of the friction force are equal, you can balance the equations. And when both are equal, further if you are increasing, then the body will be about to move. That is, the limit for equilibrium has reached. Afterwards, no equilibrium, no rest condition. So when the body is, you can also put the statement like this, that when the body is about to move, that is, it is the maximum limit for rest, for equilibrium condition. At that time, the equilibrium which we have got is called the limiting equilibrium. The friction that we are having when there is a limiting equilibrium is what is called limiting friction. This is only for limiting friction. You cannot apply when less force is acting. You cannot apply this. So remember all this. But many people are doing it. I have seen. So some teachers are also teaching like this. I don't blame the teachers. Different people have different weakness. I do have some weakness. Maybe you would have noticed it. So man is to err and to err is human. So that is why nowadays so many facilities are available. You can also browse the net. What is limiting friction? There if you see, it will be given that I have explained just now. Limiting friction, that is the maximum value of a friction as friction goes on increasing before that. What is limiting equilibrium? It is that stage when the body is at the point of moving, limit has been reached by the body for equilibrium conditions. So at that time, The equilibrium is called limiting equilibrium. When limiting equilibrium is there, then the friction existing is called limiting friction. And you can balance the forces in different directions only when limiting equilibrium is there. The body is in limiting equilibrium. The body is at the point of moving. The body is having a motion with so much of velocity. And under all such circumstances, balance the equations. 3 Newton force is applied. And the limiting friction is 10 or 15 Newtons. Simply leave it. You can write that. The problem cannot be solved. Even in the NEET examination, do it like that, man. They will give you 5 marks out of 4. Okay. So then, what we have now got is, that with whatever details I have given you, we have to see the 2 different laws that we are having for friction. The first law of friction, which is there, is the very definition of a friction itself. The first law tells us that the frictional force always opposes the motion. Better put relative motion. So, when 2 bodies are moving, table is moving with 2 meters per second, the body is moving with 4 meters per second. So 4 meters per second is greater. So 4 minus 2, the relative motion will be equal to 2 meters per second. Opposing that relative motion, we have got the frictional force that will exist. Okay.